Today what we're going to do is we're going to learn how to specify the size of the beam for a structure. So we've got this example that's here, and it says that we have a two-story frame structure with a size of 28 by 40, as shown in the figure. Assume that a bearing wall runs the length of the building on both floors. It is a two-floor structure. Determine the most efficient combination of beam, which is the least amount of steel, and columns that should be used to support the structure. And we're told to use standard I-beams. Okay, so the very first step is we have to calculate the area of the building. Now we calculate the overall area of the building, and we're also going to calculate the area of the bearing wall. So for each floor that we have, we're going to have 28 by 40, and that is going to equal 1,120 square feet. For the bearing wall, we're going to have 40 feet because we're going to assume that the beam is going to be placed on the center line and the bearing wall is going to go along the entire line. So we'll say 40 feet. And we're going to assume a standard wall height of 8 feet. And that's going to be 320 square feet. The next step is to actually calculate the loads for the building. So we've got this nice little chart here. And what we're going to do is we're going to put some titles here so we know what we're working with. So we're going to put the item, we're going to put the calculation, and then we're going to put the weight itself, and then we'll add all the weights up when we're finished. Okay, so the first item is going to be the first floor. The second item is going to be the second floor. The next item is going to be the ceiling. And then the last one is going to be the roof. Okay, so for the calculation, the loads for the floors is going to be 50 pounds per square foot. So we'll take this size information, that's why we did that size calculation, 1,120 times 50, and we get a result of 56,000 pounds on square feet, okay? The same for the second floor, so I'm just going to copy this down, and that's also going to be 56,000. And for the ceiling, the loading is a little bit different. It's going to be 30 pounds per square foot. Okay, so I'll go ahead and calculate that out as 33,600. Now the roof is going to have zero loading on the beam itself because the roof is going to be supported by the outside walls. So we do not need to account for that. Now when we total all of this up, we'll get a value of 145,600 feet, and that's our total there. Now the total load of the structure on the beam is going to basically be half of the total load. So I'm going to make a note of that here. Half of the total load, and that's going to be 145,600 divided by 2. And that will get a value of 72,800. Okay, now the loads for the bearing walls, if applicable, and we do have bearing walls in this structure, so what we're going to do is we're going to have to account for those. So we're going to calculate it for each floor, and then we'll multiply it by the number of floors. Okay, so this is where this other number, this 320, comes into play. So for each floor, we have 320 by 10 pounds per square foot, and that'll be 3,200. Okay, and then we're going to multiply that by number of floors. And in this case, we have 2. So we have 2 here. And then our total load for that will be 6,400. Okay? Now the total load for the beam is going to be basically those two numbers added together, the 72,800 and the 6,400. Okay, so we're going to add step 3 and 4 together. Okay, so we have 72,800 and 6,400. And that's going to give us a total of 79,200. Okay, now we're going to use this information to look for the proper loading. When we do that, what we're going to have to use is we're going to have to use the beam tables, and those are located here. Okay, so if we take a look at this, we can see we're going to have to look for using the size 40, okay, and we're going to have to scroll down, okay, and we're looking for a number that's above 79,200. But we're going to be using the standard I-beam, so we have to use this bottom chart. But if we look, the highest it goes is 39,042, 39,000 and 42,000. So we can't use that size. We don't have a beam that's big enough to be able to support that load. So what we're going to have to do here is we'll make a note of that. No beam large enough to support that load. So we need to add a column. Okay, so if we add a column, that is going to change our span in half. So we're going to put the column right in half. So it's going to change the span to 20 feet. Okay, and we're going to have to divide that number 79,200 by 2, and we get 39,600. Okay, now we'll look back on the chart for that. We'll go back to the chart, and we'll look at 20 feet, and we'll see that what we have is, if we go down, we do have a number here, 43. Okay, that is larger than the 39,600, but the issue is it's too big because it's 15 by 5.5. We want to use something that's below that, okay? So we want to make sure that 12 is our maximum size, because we need to be able to get in and out of the building to be able to move things around. So we want to have a maximum size of 12 inches. And also we want to make sure that we're not incurring too much damage by moving it around and transporting it as well. So we have to add a second column. So we're going to say here, we're going to make a note, beam too big, and I'll put the size in here, 15 by 5.5. Okay, and then we're going to add another column. That is going to change the span again, okay, to 13.3 feet. We're going to round up to 14 feet. Okay, now when we do that, we've got to divide the 79,200 total load by 3, and that'll get 26,400. Okay, and we'll go ahead and look for that. That's our new value that we're going to look for, 26,400. We go back to that area here, so we're looking at 14 feet, and we're going down to 26,400. And it looks like we can use, okay, this second beam that's in this row, the 10 by 4 3/4, because it's got a, let's see here, it's got a value of 28, which is larger than the 26. So we're going to write down that size there. That's the size we're going to use. So size we can use is going to be 10 by 4 3/4 inches. Now we do need to write down the size that we saw on the chart, and that's 28 kips. That's the size it's allowed to carry. And we're also going to write down the weight of that beam. The weight of that beam, we remember from the chart, is going to be 35 pounds per foot, because we'll need that for calculations later. Okay? Okay, now we're also going to have to determine the size of the columns. So we do need 2 columns. We need 2 columns. Okay? These columns are going to have to support the 28 kips. Okay, and that's why we looked up that number. Okay? So what we need to do is go back to our document again, scroll down to our column chart, and we're going to look for, and we're going to assume an 8-foot unbraced length because that's the general height for walls. Okay, and it looks like the 3-inch column will support enough. So the 3-inch column will support 34,000 kips. So we are in good shape. Okay, so we'll say the 3-inch column will support 34 kips. We are all set. So our final design is going to use two 3-inch columns, and they weigh 7.58 pounds per foot. Remember, that is given on this sheet. If we go back to the sheet real quick, it tells you how much they weigh, 7 pounds per foot. So you know how much, what kind of a fixture you need to carry that and move it in place. And a beam of 10 by 4 3/4. It's 40 feet long, okay, but we're going to use the span there, and it's going to be, the span is 14 feet. So we'll say span of 14 feet, but length of 40 feet, and it's going to be 35 pounds per foot. Okay, and we are all set. That is our design.